No matter what the function looks like, when we have our original and the inverse, we prove it the same way every time. We're first going to take the inverse function and plug it into the original. Then for our second round of proof, we'll take the original and we'll plug it into the inverse. So first I'm going to take the inverse function and plug it into the outside original. So I'm going to go take that original function and I'm going to make a nice big parentheses where x used to be. That's the only thing I'm changing. It's a huge x. So now I can go take the inverse function and plug it into the original where x used to be. So now I'm going to go take that huge original, the fifth root of x plus 3 over negative 2, okay? Now, as we've been learning, whenever you have a radical and a matching exponent, those act like inverse operations. So we're left with negative 2 minus 2 times x plus 3 over negative 2. Now, when I multiply and divide by the same number like this, those cancel out. We're left with negative 3 plus x plus 3. Negative 3 plus 3 is 0. We're left with just x. We need to get just x with our second round of proof. So we already plugged the inverse into the original. Now we need to take the original and plug it into the inverse. So I'm going to take that inverse function, and where x used to be, I'm just going to make a nice big parentheses. It's the only difference. Since I'm taking the original into the inverse, I go make a nice spot. So now I can go drop the original there, which was negative 3 minus 2x to the fifth. And now we need to simplify this down. That negative 3 plus 3 will be 0, so we'll be left with the cube root of negative 2x to the fifth over negative 2. The negative 2's will cancel out. And when you have a radical and matching exponent, you know it'll reduce to just x. We must see x is at the bottom of both for the proof to work.